Okay, in this video I am going to illustrate the most important concepts of geometry so that you can excel in the in the math portion of the SAT. Okay, this is a basic review. If you're ready to take the SAT, you should have a good grasp of geometry, but just in case, here's a quick run through. This is a point, single dot, one dimensional. This is a segment. There are two endpoints. It stops right there. This is a ray. There's one endpoint and it goes on forever in another direction. This is a line. It goes on forever in both directions. This is a perpendicular angle. It goes like that and it forms a right angle. And these are parallel lines. They never touch. Okay? Doesn't get simpler than that. Okay. This is an isosceles triangle. What an isosceles triangle is, exactly two sides are the same. So the measure of these two sides are the same and they're denoted by this little mark, and by one of the principles of geometry, the opposite angles of those sides are also equal. So if this segment was 6 and this was 6, then those opposite angles would also be the same. Let's say 40 and 40. Okay, a very important part of geometry. This is called an equilateral triangle. All three sides are the same, which also means that all three angles are the same. And if all three angles are the same, it must be 60 degrees for each angle. Why? Because in a triangle, the sum of the interior angles is 180. What is the formula for the sum of the interior angles for regular polygons? It is n minus 2 times 180, with n being the number of sides in that particular polygon. So if we take a triangle, it's 3 sides minus 2, 1 times 180 is 180. Beautiful. Now, if we were to bisect this triangle right down the middle like this to form a right triangle right here, we would get this triangle. And this is called a 30, 60, 90 triangle. The 60 remains, and you know this is a right angle, so this right here must be 30, because the triangle must add up to 180. There are special properties of 30, 60, 90 triangles that will come up in SAT over and over and over again. And essentially they're shortcuts. In a lot of problems, you can use a Pythagorean theorem to find the length of the sides. But a much quicker way is to use the 30, 60, 90 principles along with the 45, 45, 9 principle, which we'll go over in a second. So the Pythagorean theorem is a squared plus b squared equals c squared. So for example, 3, 4, 5, 6, 8, 10. These are called Pythagorean triplets. But an even quicker way, let's say this was 6, 8. We want to know if there's 10, right? Okay, let's take that off for a second. And just get to the point. 30, 60, 90 triangle. The side opposite of 30 is x. The side opposite of the 60 is x root 3. And the side opposite of the right angle is 2x. Okay? That's what you need to know. They give this to you at the beginning of the section when you take the test, but it's also good to know because it's quick. Math is a lot about timing. Okay? Next, we have a square. Square means a quadrilateral with 4 equal sides, which also means 4 right angles. Now we have that. If we were to bisect it here from one corner to another, we would get this triangle, which is a 44, 45, 45, 90 triangle. And in this case, because it's 45, 45, it is also an isosceles triangle, and it also means the sides are the same. So let's give it x, x. In this special right triangle, we have x root 2 as the hypotenuse. Okay, keep that in mind. This will save you lots of time on your problems. Okay, now moving on to